variables are represented in two forms. One in standard form, the other one is in general form. So in standard form, we got standard form, which is written as that, which is x minus x all to the square plus y minus k inside the brackets all raised to the square, which is equals to r square. And in general form, we're going to expand that standard form. And what does h represent and k represent and r represent? Once we go through the derivation of second of equation, then we'll move further. General form, this is not a general form. We'll have to expand. So using one of the techniques normally we apply it for difference of two squares. You can recall simple example. I'm putting this one. So to expand, we take the square of the first term, we take the square of the last term, and we multiply the terms inside the brackets multiplied with the powers. So it's just like a squared is okay. A squared. We take b squared. We put them, and then we multiply. A multiplied by b minus b. Minus ab multiplied by 2. Minus 2 ab. So that technique is just the same, like you expand and then you simplify. A minus b squared is like a minus b times by itself. So a minus b times a minus b. So it's just like we're expanding the brackets. A multiplied by b is, rather a multiplied by a is a squared. A multiplied by minus b is minus ab. Minus b multiplied by a is okay, minus ab. And minus b multiplied by minus b gives us okay, plus b squared. Now collecting like terms, we have a squared minus ab minus ab minus 2ab plus b squared. So just the same as we're using the technique, which is we take the square of the first term, we take the square of the second term, we multiply the term inside the brackets. Whatever answer we get, we multiply with 2 again. So that's it. A squared, we put them here, minus b squared. We know that we're going to get positive, so positive b squared there. And then a multiplied by minus b gives us minus ab, multiplied by 2 gives us minus 2ab. So that technique we're going to use to expand general form. Now here, we take the, it's a difference of two square now. Like the one we take a squared and b squared. So here it should be x squared, and then here a squared, okay, x minus x multiplied minus h minus 8x multiplied by 2 minus 2x. Alright, so apply the same. We got y squared, y times minus k gives us minus ky, yk, and then multiply by 2 gives us minus 2, okay, ky, and then okay, plus k squared. Alright, we have r here. Let's bring r. When it's positive r, when you bring it to the left hand side, it becomes minus r squared, okay, equals 0. Okay, in those terms, let me bring the highest degree to one term. So we got highest degree of 2, which is x squared and y squared. The others are constant, so let's leave it as it is. Okay, I'm writing x squared plus y squared. Okay, now we are having minus 2x. Alright, we have minus 2ky, and then we have plus h squared, and we have plus k squared, and we have minus r squared, all equals to 0. Okay. in this form, this is our general form. General form of the equation. Okay, for now, we'll be looking at standard form. Standard form, and given the center and given the radius, how to come up with the equation that we're going to expand to come with general equation. Okay. But first thing first, let's derive. So how do they come up with the standard form equation of a circle? So let's say we have from a Cartesian plane, meaning x and y plane. Alright. Okay, let's say we have a circle, maybe from the first quadrant. This is x, this is y. Okay, let's say from the circle we have a center, which is O. And then let's say from center we draw a radius from O to some particular point, let's say P. Point P. Okay. Okay, let's say from where the center is, we have a coordinate. Let's indicate, let's say for x, let's say it's 8. For y, let's say it's k. Okay. And then the other point P, where the point P is, let's say x. And then where the point P is for y coordinate, let's say it's y. So we've got 2 points. Or you can just write x1, x2, y1, y2, doesn't matter. In your book you see that center they labeled A and B. Coordinate of center is A and B. For x, the first point they put A. For y, the first point they put B. Okay, with origin here, 0. So now look at it. Given that diagram and the coordinate, we know the distance from the center to the circumference is radius r. It's radius r. So center O point, alright, point O or center, the coordinate is coordinate O. Okay, good. H and K, coordinate of point O, and point P, coordinate of point P. Okay, point P we got x and y, and then using distance formula to find the radius. We want to find the radius now using the distance formula. Distance formula, by looking at the graph, look at it. You can form a right angle triangle. Can you see? You can form a right angle triangle. And given the length from here to here, we have x and we have 8. And from here to here, we have k and we have y. Can you see? So you have the distance there. So to find the longer distance, it's a right angle triangle. Using Pythagoras theorem to find the r side, we use the Pythagoras theorem. C squared equals to a squared plus b squared. So c squared equals to a squared plus b squared. Okay. We want to find the difference between, for instance, if it is maybe 4 here and if it is maybe 12 here, then the distance between these two is 8. We minus the second point. Okay, minus the first point. Can you see? Likewise for the vertical distance as well. So using that technique, distance OP of R, the length OP of R squared is equals to, okay, no, I'm just indicating the value. Now it will be x minus 8. So x minus 8, which is and then squared. That is length A. Can you see side A now? We wanna look at side B. Plus side B, we got y and k. So y minus k squared. And by seeing this, we arrive in our standard, okay, form of equation of circle, standard form. Can you see? They just apply the distance formula of Pythagoras theorem to find the distance of radius, which they come up with this equation. Okay, one more thing. If so, now look at it. Now you having this, and now you know what H and K represent. So H and K represent point O, which is center. So now we know that our center of circle, we know that it's H and K. The coordinate of the center is H and K. Can you see? The coordinate of the center. That particular point center, coordinate is H and K. Okay? And our radius is R, distance R. So we got there. So now we know that H and K represent center. Okay, from the equation, look at it. We got minus sign there. Can you see? So sometimes given the standard form, they will give you a coordinate, they will give you negative coordinates. And once negative gives you positive and so forth. Alright, one more thing. Having that standard form, if the center is here, around here, let's say. Now, if the center is origin, your H and K coordinate is HK. If the center is origin, your H and K will be 0, 0. Can you see? It will be 0, 0. So once 0, 0, when you substitute into the equation, x minus 0 is 0. X minus 0. X. Y minus 0? Y. So now you have x squared and you just have y squared. So if the center is at the origin, then our equation reduces to x squared plus y squared equals to r squared. If our center is at the origin, so your equation reduces to this case. So those are equation of circle. Okay, for general form. Now we're going to move further, or before we move further to general form and go to computing square, look at the example A there. We got example A. Look at it. Let's go through it. Example A, find the equation of the circle centered at. Coordinate is 1 and 2 and with a radius of 4. So center, we have 1 and 2. Radius, okay, 4. So from there you just substitute into our standard form equation. So x minus our h is 1 square plus y minus our k is 2, which is equals to our r is 4 squared. Speak up. I didn't put square. Okay, good, very good. So now that is our in the standard form, which you can write as that. You can solve for radius. So now 4 square is 16. So that equation is in standard form. Is that clear? That equation is in standard form. When the question asks you to leave it in standard form, okay, you can leave it as it is. If it says general, then you have to expand. Is that clear? So let's expand. From the solution, they expand standard form to give in general form. So here, using the technique, we square the first term, which is x squared. Okay, x times minus 1 minus x. Minus x times 2 okay. And then minus 1 squared, 1. Okay, we have y squared. Y times minus 2 gives us minus 2y. Minus 2y times 2? Minus 4y. And then minus 2 squared? Plus 4. Okay, let's bring 16 in. To the left hand side, it becomes minus 16. Now equals to 0. So now, let's arrange them. Okay, x squared plus y squared. We have minus 2x minus 4. Alright, the whole numbers 1 plus 5, 1 plus 4? 5. 5 minus 16? Minus 11. All equals to 0. So that equation is in general form. So you got a standard form and general form. Okay, let's look at example B there. Find the equation of so-called center there. Minus 3 and 4 and with radius 2. Okay, we got center which is okay minus 3 and 4 radius 2. Same thing, we substitute the values into a standard form. X minus h is so minus 3 all square plus y minus 4 square equals to 2 square. We got minus minus. From the equation it contains minus sign. Can you see? So therefore x minus and the h value is minus 3. Therefore I'm putting minus 3 here. Can you see? So therefore the minus minus become plus. So we have x plus 3. Okay, all raised to the power 2 and y minus 4 raised to the power 2. Okay, let's expand the brackets first. Alright, x squared. Next
3x minus plus 6x.
Pick up. Alright, good. Plus 6x. Okay.
Plus 9.
Plus. Alright, next.
Y square.
Good.
Plus 16. Minus
8y.
Alright, minus 8y and
Minus 6. Plus 6.
okay. And 2 squared we know that it's 4. When you bring it over it becomes minus 4. So now you can go ahead. We have x squared plus y squared plus 6x minus 8y. Okay, we have 9. 9 plus 16 is 85 minus 4. Okay. That is in general form. That is in standard form. So that's how. So we know that h and k is the center. Is that clear? H and k is the center. So you just substitute whatever center point that is given. You substitute into the general equation, standard equation here. Okay. Sometimes question will specify. They will say leave answers in standard form or in general. Sometimes, like from our example, doesn't specify. But from the solution, they express them in general form. Okay. So when they don't specify, you always expand the brackets and leave them in general form. Is that okay?